Okay, so again, I apologize about my audio. It's going to sound weird. So I coded this up, and I think I have a finished product that we can be happy with. So what we have here is a bike, front wheel, rear wheel, wheelbase is here. So right now the wheelbase is set at 1 unit, and so what I'm going to do is imagine that we're going to turn the wheel, aim it in this direction to some point. That point will determine an angle, which we'll call theta, this angle, and that's fixed, and I can adjust that angle as needed, and I can also choose the step size, which is how long I want this little jump to be. So this is what I'm calling my delta. Of course, what we want is that delta basically be infinitesimal, but we'll blow it up just so we can see it. And I'll take the delta out of here. So what happens on the next step? Well, this bike, the front wheel is going to move to here, and the back wheel will have to move to a point that lies on the line segment connecting these 2 points. So we'll have something like this. So the bike has moved from here to here. Now I have the computer calculating the distance between this red point and this green point. So the green point's the front tire, red is the rear, and the coordinates of the front tire are here and the coordinates of the rear tire are here, and the computer is actually verifying that the distance between those two is still 1. So I'm maintaining the wheelbase there. Now if I now step forward to the next point, it should be up there, and my bike will move up to that point. Now to verify that this is moving properly, what I'm going to do is I'm going to show the bike up here. It's moved there. Let me move the bike up there. So this is showing the trace of where the bike was. And now let me throw some angles in here so we can verify everything is correct. So when the bike started here, it was pointed in this direction along the x-axis. The angle here was theta. The new position of the bike here to here, the bike is now pointing in this direction of this dotted red line, and the wheel is turned at the angle theta. So here's theta. This angle is the same as this angle. Remember, I can adjust those, smaller or bigger. And then this point, orange point, will now head to the new front tire point, which is up here, and here's where it'll end up. The front tire is now here, and again we repeat the same process. Here's the new direction of the bike, rotate by theta, and here's where we're headed for the next point. So let me bring another point in here, and we can continue this, and I'll have to zoom out a little bit so we can get a feel for what's happening. Now what's slowing my computer down a little bit is the drawing of all these dotted lines, so hopefully you'll believe at this point that all my angles are correct, although I'll do this just to make everyone happy. Let's see here. There we go. That up a little bit too much. Okay, there we go. A couple more iterations of this, and you can see what we're getting here already. And I'm going to take the lines out, speed up my computer. And then now, remember, this was my bike. These are the points it's going to be. So the bike is going to be moving like this. And I'll finish it up. I'll bring in a couple more iterations. If I keep going, you can see what's happening here. So our idea of having the circle within the circle looks pretty good. Now what I thought was really cool is one more thing I can show you here. Let me bring the bike back to initial position here. Actually, I'm going to just put it at the first step, take that angle out of there, and then check this out. If I make my delta really small, then we're getting to the infinitesimal here, and Let me just adjust my angle just a little bit so I can widen this thing out. Yeah, that's good enough. And then let me throw more iterations in here. And I'm going to zoom in just a little bit. And then now, a couple more iterations. Check this out. So here's the bike moving. You know what? I'm gonna bring that back. I'm gonna make my delta even smaller. I'm gonna scrunch it up real small. Yeah. Not quite that small. There we go. More iterations. I think I'll make my wheelbase a little bigger. There we go. Let's see how this works. There's my bike moving. There it is. And let me throw as many as I can here. So there's my bike moving. Now I should be able to animate this, but I'm having some problems. I should be able to press play and it should move the bike automatically. For some reason it's not wanting to do it. I don't know why. So I'm just having to drag it. But you can see pretty clearly that we're getting exactly what we thought we'd get. And I'll increase the delta just so we can again get the confirmation that we have a circle within a circle. Now, the other one I had, that was my old one. This was after I was able to generate the equation of the inner circle. And so this is just to verify that the tangent vector here, now this is not correct, it's just to represent the direction. So the velocity vector for the back tire runs perpendicular to the radius of the circle, and the velocity vector of the front tire runs perpendicular, and that created that right triangle, which is where I got all the information for actually constructing the circle and getting the angle here. So moving that around. See, that's what the other one's supposed to do. It's supposed to animate like that. But this was just me having the computer calculate distances to make sure everything was working out right, which I did not tell you to look at here, but notice that when I move this bike around, notice that the distance between the 2 points that are connected here is being calculated by the computer to be 1.5, which is the wheelbase. So as I move that bike around, notice that 1.5 up there just stays constant, which it should. So I feel very good that this is enough for us to maybe set this to rest. We'll see what you guys think of it. All right, talk to you later.